Stand by. We'll be right back with Cliff High as we continue our most fascinating 2 hours. So stay right with us. And we continue our conversation with Mr. High of HalfPastHuman.com. If you reload Rense.com and look in the guests section, under Cliff's name, you'll see special material and images for tonight's conversation. You're welcome to wade in. We're going to be working through that as we continue. And just for fun, I entered 2012, just 4 little digits, in the Google search engine. 392 million returns. And growing every minute.
A curious meme, yeah.
Yeah, for sure. All right,
go ahead. Unlike any other Millennial Madness episodes in the past, going back as far as 999 crossing into 1,000, we had some strange things there, but it all faded by this time, so it's quite odd. Probably it makes sense to just step through the idea of the theory, the sunspot cycle, and then say why it's important in a separate little bit.
Okay.
Okay, so basically here's the idea. The sun rotates at multiple different speeds. As far as we're concerned, the ones we care about are the polar speeds versus the equatorial speed. And there is a difference because while the sun has 99% of the mass in the solar system and is the giant big guy, it only has 1% of the angular momentum, which is to say the centrifugal force, the whirling around effect. And the planets, while they only have 1% of the mass, have 99% of the angular momentum. Since they whirl around at the equatorial plane of the sun, they have a tendency to yank the sun's equator around faster than its polar spin. The difference is key because the polar spin is 37 and some fractional part number of days, and the equatorial spin is 25 and some fractional part number of days. And the fractional parts are important. They're, in fact, the key to the whole understanding of what Garrow found and what Maurice Cottrell found within the various Mayan and Egyptian encodings.
So just to help people out, if someone were standing at the very top, the North Pole, for example, they would rotate, their body would spin at...
Once every 37 days, they would do a complete loop.
And if they were standing at the equator?
They'd whip around once every 25 and some fractional part.
Okay, just wanted to get that mental image. All right.
Yeah, so they're whipping around a little faster than the at the equator. And you can think of it this way: if you put a 2 or 3 pound weight, even a 1 pound weight on an end of a string that's somewhat long, and you started spinning and you let that string out, the more the string you let out, the faster the string will appear to be accelerating around in the arc ahead of you. So it'll actually seem to tug on you. And it's the same kind of effect that's going on here. And basically what happens is that over a course of this whole process, by the way, accounts for sunspots, why we don't have sunspots sometimes, why there's an 11-year cycle involved in the sunspot activity. It accounts for the periodic sun flips of its poles, as well as the shock that comes out later and hits the rest of the planets. And it's all internal to the solar system. And it may be that every solar system works this way, and Gerald may have indeed stumbled on a basic rule of how solar systems work, and they may have to work this way. I stumbled on Gerald's work because I was starting to write a book about taking the transition from a class 0 or type 0 society to a type 1. And I had a fundamental question as to why we had not achieved that yet. And I started looking at some other periodic stuff and was led to Gerald's work. In any event, though, the idea is that as the sun spins around faster at the equator, it will spin around and lap. The equator will lap the pole every 87 days, and some fractional part thereof. And as it goes around and laps the pole, it pulls on the magnetic windings, if you will, of the sun itself, bearing in mind that the sun is a giant electromagnetic thingy sitting up there, arcing off so much that it gives us light and heat, X-rays, and all other kinds of energy. And when it's getting its magnetic limbs tugged, that's when it actually ends up causing the sunspots.
So we could say we've got strings, as it were, coming out of the equator headed north, and another set of strings headed out of the equator to the south pole?
No. They're
How does
the
it
north
work?
and they go to the south, and just like the magnetic lines out of the top of a magnet going to the south pole of the magnet. And they're undisturbed. If the sun just sat there and none of the planets moved, they would just be totally vertical, connecting the north and the south pole.
So one total loop from the top to the bottom, all the way
Correct.
around.
And actually it even goes internal into the back through the middle of the sun to come out the other side, so to speak. So
I was thinking of a sideways toroidal donut kind of a thing, but
yeah,
that's
no.
not
It ends up looking like that in the end, but it doesn't really start out that way, and nothing ever comes out of the equator. What happens is that the stresses, the gravitational forces, actually are so intense at the sun's equator due to this extra spin, the pull of all the planets yanking on the equator there, that it distorts magnetism itself. And so it bends the magnetic arms in the direction of the rotation. And so these arms very much start to form almost a 90-degree bend in them as they're pulled at the equator, and because they emerge out of the top of the sun in the North Pole, and then want to head naturally down to the South Pole, only they can get only so far into the equatorial plane, and the tug of the planets pulls them and distorts them. And the same thing is true from the south attempting to get up to the north. And so either way, you're looking at just a mirror image. In any event, though...
So you like to call these windings?
Correct, yeah.
Right.
And basically it's kind of like trying to, put a tack in the top of a croquet ball and tie some yarn to it, and then you start winding the yarn around the croquet ball, and it's going to be very much the same effect.
Okay, that's a good image. Forget that. Windings, think of that. Yarn, croquet ball, tack in the top, and then wind the yarn around the sphere of the croquet ball, which would be the sun. The distortions included, of course. So over time, it would seem to me, and I think we're going to get there, that these windings become rather constrictive on the overall ability of the sun to flex itself, so to speak.
Yeah.
But we'll find out more from Cliff in just a few. Hang on. All right, if you can, take the link in guests and go to halfpasthuman.com and look at the special material for tonight. You can see drawn very nice graphics of exactly what Cliff is explaining, how the magnetic fields come out of the top and go to the bottom and vice versa, and how as this big machine, this big generator spins, especially at the equator, how it distorts these magnetic waves of flux, and they're called windings in the Cliff High vernacular, and it works very well. Okay, go ahead, Cliff.
Well, basically, you're correct with our little croquet ball kind of image. Ultimately, you get too many windings and too little space. And even though they're magnetic and not actually physical filaments, the distortion levels build and do not dissipate simply because the planets continue to go around. Now, the beauty of all of this is that the Mayans knew this precisely. This is why the long count was done in days. That's why days matter. For instance, our calendar, we usually like to think in terms of weeks or perhaps months, and these are administrative kind of decisions that are made, and they're administrative divisions that are really rather artificial. The Mayans, on the other hand, and the Egyptians had day calendars that were very specific about this. Well, the reason it turns out that we can be specific about it is because the math is so precise that given the current state of the orbit as measured by the precession of the equinox, we can actually determine from period to period when these windings will get to be too much and go into what we can think of as an expansion phase. Basically what happens is the internal generator magnetism gets really twisted up all the way from the poles down to the equator, and we start getting very chaotic forms of sunspots instead of, quote, regular sorts of sunspots. A regular sunspot can be defined as one that will appear and then stick around on the sun and go for between 25 to 30 days, usually no less than 2 weeks as it travels around to the backside and may appear on the other side of the sun. And this is a coincident feature of the internal tetrahedron hyperdimensional nature of the sun in all spheres in space, in coincidence with the magnetic arm crawling up its face. Now we're into a phase where predictably, where the magnetic arms are not only wrapped up in windings, but they're starting to twist in on themselves. And eventually what happens is the whole thing gets so twisted up and there's so much bottled up magnetic energy, it becomes very much like a pressurized magnetic containment vessel, and something has to give, basically.
Wow, okay, I got it. So the windings literally cover the surface of the sun, to keep this real simplistic. And
if we could see them indeed.
If we could.
Yeah.
They bind it, they've completely encapsulated it,
and
basically.
Pressurize it. They've
and
caused
pressurized
a change
it.
in the color.
Exactly.
They've caused the increase in the intensity of the sun over these past few years. They've led to the situation where even NASA's astroevolutionists are saying, we don't know what's going on. This is a weird cycle. We should be into solar cycle 24, yet here we are in the weakest one ever. Are we going to go